Hi guys, welcome to the new week here on this new chapter for turning effects of forces. All right, so for this chapter, you need to first understand about perpendicular distance. Most students, they cannot solve this question well because they do not understand perpendicular distance. Okay, so in this chapter, let's take a look. For example, this is the pivot. This is the force. Where is the perpendicular distance? Remember, the first step you need to do is elongate the line of action. Elongate means extend. Extend this line of action. That means the line that passing through by this force, okay? This is called line of action of this force. Then draw a 90-degree line from the pivot to the line of action. So draw from here to here. This is then perpendicular distance. All right? Let me ask you another one. What about you have a force in this direction and this is the pivot? Where's the perpendicular distance? What you need to do? Just elongate the line of action. Elongate the line of action. Can you see that? Eh? Okay, this one doesn't look straight. Okay, elongate the line of action. So where is the perpendicular distance? The perpendicular distance will be this part, right? That is the very small perpendicular distance, all right? So now let's take a look at the first question. Look at this one. They say, what is a moment by force F? Where's the force F? This is the force F. This is the point P. Where's the perpendicular distance? Must be this is the perpendicular distance because this distance is 90 degrees to the F, right? That's what answer is. F times SC. Okay, now let's take a look at the question number 2. Now, this question is more difficult. Now, they say that there's a force applied here to topple this block about this curve. Now, you need to understand what are the forces acting. You need to know that this is the pivot. When you push a force here, this block will topple about this pivot. Okay, they will just topple, right? Now, you need to first step draw free body diagram. What is a free body diagram? All the forces acting on the block, which means the F and the W. All right. When they by right, there is a normal force. By right, there is normal force. Okay. But the problem is when they about to topple, this surface will be lifted up, right? When they lift it up, there's no more normal force by the road. Okay, so we do not draw normal force. So we do moment analysis. This weight times this perpendicular distance d1, there will be anti-clockwise moment, right? This will be anti-clockwise moment. Anti-clockwise. This F, sorry, this will be clockwise moment. This will be clockwise moment. And then due to the F, it will generate anti-clockwise moment. Then only they can balance, right? So this F and this is a pivot. Where's the perpendicular distance? Must be D2, right? So in short, W times D1 equals to F times D2. Okay? And what is the weight here? The weight here is, they say that it's 6 kilogram, right? Means 60 Newton. So this is the W. The D1 is this one. The D1 is 10 cm, right? 10 cm is 0.1. F, you do not know. This distance is this 15, this 40. So this must be 25 cm, right? So it's 0.25. That's why the answer is C, 24 Newton. All right, this question is about stability. Now, how much you know about stability? You need to understand why this one can be balanced at the edge. Why it can be balanced? Where is the center of gravity? Remember, center of gravity must be always below the pivot. Then the object will not rotate. This is the pivot. Okay, this is a pivot. The CG must be directly below it. This is a CG where the weight acting, the whole weight of the horse and this tail and this mass, everything add up. The CG will be at this point. Now, do you realize that? CG not necessarily within the object. Okay? Now, so it can be outside the object. In this case, it is C. Why it is not at D or at B? Because if the weight is at B, there will be a big problem. Assuming, and let's say somebody choose B as the CG, right? The center of gravity, then the weight will act here, correct or not? But the pivot is here. So they will generate clockwise moment about this perpendicular distance, right? then this horse will topple clockwise, right? Correct or not? So that's why CG cannot be at this point. There must be no perpendicular distance. There must be no rotation. Okay? So they say stay the rest of a balanced toy near the edge, the rest position, right? So when they're at rest, that means CG must be directly below the pivot. So the best answer is C. Okay, let's go to another structured question. This question is more difficult. Now, you need to first draw the free body diagram. Take a look at this question. You have this bucket of 20 Newton here. This weight of the whole ladder, 60 Newton. This shoulder is giving an upward normal reaction force, right? And the question asks, what is the force acting at X? If you read the question carefully, yeah, there's a vertical force here acting at point X. Let's answer the question part by part. State the principle of moment. Do you recall principle of moment? What is principle of moment? You need to talk about in equilibrium. You get 1 mark already, okay? Sum of clockwise moment about a pivot is equal to sum of anti-clockwise moment about the same pivot. You must write exactly the same word. You know, most of the students, what they write? They totally forgotten to write this first part, in equilibrium. They just say, sum of clockwise moment equal to anti-clockwise moment. Do you know you get 0 by writing that? Understand? So you must remember to write this first in equilibrium. And do not forget about a pivot and about the same pivot. You know, all these details are very, very important to get full marks. Okay? Don't forget that. Determine the force X. They ask you to find the force X. So many forces here. We also do not know whether the force is up or down, right? And how are we going to stop that? Okay, the rule is very simple. After you draw the free body diagram, which is this, and actually another force here, but we do not know, right? So we don't care the force first. We don't care the force first. Later, then we find, okay? First, we need to identify, if only acted by these 3 forces, what is the net moment? What is the net moment? To find net moment, you need to find a pivot, right? In this case, I use this as the pivot because this is unknown. This is a normal reaction force. We do not know the force, right? So we put that as pivot, okay? So we put this as pivot. So after we put this as pivot, then any moment produced by this force is 0, right? That's the reason, because we do not know this value. So put here is the best. We don't care the normal reaction force already. Okay? So in this case, what about the moment produced by 20 Newton? It must be anti-clockwise moment. How much? 20 times 1.3, right? This one, 16. You generate clockwise 20 times. 16 times 0.85, right? Okay. So this is the clockwise moment produced by 16 Newton about this pivot. This is the anti-clockwise moment about this pivot. So net, what is the net moment now? Let's find out. So 16 times 0.85 is what? Is 13.6 clockwise, right? Anti-clockwise is 20 times 1.3. 20 times 1.3 is 26, right? So which is bigger? That means 26 bigger than 13.6, right? That means the net is anti-clockwise moment. Okay? In other words, this guy, if only acted by these 2 forces, there will be anti-clockwise moment, right? But then it is not in equilibrium. This one must provide what moment to balance it? Now you got excess moment, right? Excess how much? 36 minus 13.6. Excess 12.4 Newton anti-clockwise. So you must, of course, add a clockwise moment to balance it back, right? So in this case, the force here must acting downwards. Because this force will produce clockwise moment to balance the excess anti-clockwise, right? About this pivot. Okay. So what is this moment? F times 0.6, right? No. F times 0.6 is equivalent to 12.4. So F is what? 12.4 divided by 0.6. You got me? So that's why the answer is 21 Newton. Okay, that's how we solve this problem. Okay? All right, now let's move on to the new question on another structured question on stability. Just now was on moment, now on stability, right? Now, this one, you need to draw the free body diagram as well. Draw all the forces acting on the object. That is a rule, you know. If you do not know how to write the free body diagram, like what I've taught you in the previous chapter, right? Then you cannot do this chapter. There's a reason why you need to master the dynamics before you come to turning effects, okay? So this 22 Newton, this is F, all right? And this is a pivot. Where's the perpendicular distance? force here, pivot here, this is the perpendicular distance, right? 11 cm. So this one instantly you will get 22 times 0.11. Okay, and this will be anti-clockwise moment. Okay, then F leh? Where's the perpendicular distance? This is a pivot. Obviously 24 cm, right? Many students choose 25 as the pivot. That's wrong. Okay, although it differs by a little bit, but it's wrong already. Okay, so please take note. So F times 0.24. This is then clockwise moment. Now you use this, equate to this. Then only you can find F. Okay, so the answer is 10 Newton. Okay, 22 times 0.11, F times 0.24, right? Okay. Now a counterweight is added at E. This is a pivot again. A counterweight is added at E, the center of gravity of the sculpture. With counterweight is at the pivot. So this is the counterweight here, right? The sculpture is rotated clockwise with the position as shown here. It is held, then carefully released. It is then released. And they say that they stay in that new position. And do you know what does that mean? They stay at that new position? Tell me, we have 3 types of equilibrium, right? We have stable, unstable, and neutral equilibrium. They stay at that new position. What is the equilibrium? It must be at neutral equilibrium. Okay, and you remember neutral equilibrium? For neutral equilibrium, the CG must be at the pivot. It's at the pivot. You must say CG is now at pivot. Why? So that there's no net moment. They will just stay there at the new position. Okay, they just stay there. They will not rotate anymore. That is the idea of stable equilibrium. Now, so in other words, the pivot is here, right? After you add the weight by right, if you do not add this counterweight, let's say this one doesn't exist, you only have the bird, the weight is here, right? They generate anti-clockwise moment, right? But after you add the weight here, then the weight, the CG no longer here, the CG will be here already. The CG will be exactly at the pivot. You see that? The weight will be exactly at the pivot. When the weight is exactly at the pivot, is there any moment? There is no moment, right? That's why they can stay in a new position. Okay? Can? So this is what you need to write. Please write it down, okay? CG is at the pivot and no net moment. If you don't write this, you write this also can. No perpendicular distance between line of action of weight to the pivot, but this is very long-winded, right? Can? That is good enough.